Okay, so we're going to keep going now. We're going to talk about the histogram tool, where it's used for presence and absence. Then we're going to talk about fixturing, okay, because we're going to want our regions to move with our part. We're going to actually create a fixture tool. We're going to look about the terminals to pass the data back and forth between them. And we're also going to talk about coordinate spaces, because we can't really talk about fixturing unless we talk about coordinate spaces. So let's talk a little bit about a histogram tool. What is a histogram? I'll give you a hint. It's not necessarily a vision tool. What is a histogram?
Chart of pixel intensities?
For us, yes, it is a chart of pixel intensities. But in the truth is a histogram is just taking different categories and showing you how many of each is in there. So usually on your horizontal axis is how you're delimiting the categories, and on your vertical axis is your amount. So yes, for us, what we're doing is we're looking at grayscale values. Okay, and we're counting how many pixels of a certain grayscale value is within a given area. So that's what we're looking at. Okay, so this is what a histogram might look like. So all the way over here would be black pixels, and all the way over to here would be your white pixels. And it just shows it along the graph what happens. So it's great to be used for presence of absence. Presence or absence of something within the image. Also monitoring the light level. A customer might put it off to the side where their part isn't. So they're kind of looking at their background, like maybe their conveyor belt. And what they're doing is they're checking the average value of the light, because lights will start degrading over time. Maybe not so much LED lights, but some of the other lights will start degrading over time. And what it does is it kicks it back to like the PLC or something and say, whoa, your light's starting to get low. You might want to change it before it gets so low that it's actually going to affect the vision tools, so that you can be, oh, can you believe it, proactive about something instead of reactive.
Can the vision tools adjust for the lighting?
Oh, you could potentially feed that back to let the vision tools adjust for it or not, but this one's just letting the PLC know your light's getting low. So then, you know, it doesn't get so low that then it actually starts affecting the vision tool, saying, whoa, you're not giving me enough contrast. So that's it. But yes, you could feed that value back for a threshold. You could feed it back, so maybe it increases that brightness level or something. It could. Now, if your light's really degrading, you got to change it. But it can be something that you can do some type of arbitrary type threshold point and feed it back. Sure. It's also for uniformity of grayscales within the image, because you can see where all the grayscales lie, as well as the distribution to be set up to another vision tool, much like you're saying, well, you know, what's going on, what's my mean value, how should I set what that threshold should be. So when I put a histogram in, of course I'm going to take the input image and have it attached to the output image so that it's feeding in an image to the tool. Then I'm going to have 3 images. You're going to notice most tools usually have 3 images that it gives you. You're going to have your current input image, your last run input image, and the actual histogram, last run.histogram, which is the actual graph that you're looking at. So your current input image is going to be what's the next image that it's about to analyze as soon as it runs the tool. And then the last run input image is going to be what it analyzed. Now the truth is it doesn't really show anything on the screen, so it doesn't do any changes there, but that's the last image that it had run upon. And then, like I said, on the histogram one, the last run histogram, it actually shows you the histogram, so you can see what it looks like. Now it's a pretty small tool. There's not a lot to it. So your first one is just going to be setting up the region, because you're setting up what is the region that I'm trying to look at these pixel values. I'm trying to look at the grayscale values. So choose which region you want. Do you want it to be the full field of view, or do you want to actually set an actual region in there? Remember, if you're setting a region, you would set your region on the current input image. That's what's going to actually house that little box for you. Then you have your graphics. What do you want to see? Okay, do you want to see the histogram? Do you want to see the mean value? Maybe you'd rather have the median value. So it's going to show that there for you. And then also you can show your region actually being on there or not. And finally, you have your results. So your results are going to tell you, like in this case, what my minimum grayscale is, my maximum, all this deviation, standard deviation, variance, the amount of samples. And then it's also going to give you how many of each grayscale values it is. So like at grayscale 87, it's telling me I found 98 pixels that were grayscale 87. At grayscale 88, I found 110. And then it's showing you the cumulative percentage. That by the time I get to 103, 12.1% of my region was 103 grayscale or less. Okay? So it kind of gives you some information there.
Are the counts cumulative, or are they specific for the grade level?
The counts are specific for that grade level, yes. So it's not, yeah, because you could never go down if it was cumulative. So I have like 110 to 96. So that's just saying just for that grayscale level, how many fell in there. Okay, so let's go ahead and do coordinate spaces. So what's a coordinate space? Well, a coordinate space is going to give us a numerical framework so that we can express our location of our points as well as the difference between them. Okay? So they could be calibrated, like I could say I'm going to calibrate it to millimeters, but I'm also going to base it from where this label is. So everything's going to be based from the label. Or I could say, yeah, I'm going to calibrate it, but instead my calibration is going to be based in the upper left-hand corner. Or I could just shift it. Okay, don't calibrate it, still in pixel coordinate, but I'm going to base everything off of where I found this particular shutter. So I can choose how I want to move things. And there are a few different ways that you can create a coordinate space. You can do it through fixture tool or fixture endpoint to endpoint tool. So these are just moving where your location point is. It does not change calibration, does not change, just moves where your location point is. Then you can also calibrate. So you can do either calibrate endpoint to endpoint or checkerboard calibration, or you can also manually configure your own 2D transform and pass it in, because everyone likes doing that. Yeah, I'm not covering that. Okay, they say later in the section they're lying. Liars! So no, it's just, but there is a way to pass in your own transform. So let's start with our root space. Okay, our root space is our basic space. That's our, I say pixel space, but I like to put that in quotes because there is a pixel space, which isn't the same. But it's the camera. It's the actual imager on the camera taking its pixels. So it's the upper left-hand corner. X is going to go across. Y is going to go down. Okay, so that's your base root space. Now with root space, if I do some stuff that does some image processing or subsampling, even though my image might get a little bit different, it still knows what the pixels are based on what the previously subsampled one was. Okay, so it keeps that identity there. It's still staying within your actual camera's acquisition space. Does that make sense? So it's still staying with the basics. With that, you have your root space, that's just the acquisition. You can create your own spaces. And creating your own spaces would create a user space. So you can create what you want to have things based off of. You can determine what units it should be. You can determine what handedness it should be and how it relates to the root space. Because it needs to know, okay, I'm taking the image off this camera. How do I need to transform it? How do I need to alter it so it's going to make sense for what you're asking me for? There's this concept called pixel space. It's almost like root space. You're still the upper left-hand corner, and it corresponds to the pixel images. But if you do subsampling, that connection ends up getting gone. It actually takes the whole image and makes it smaller and stuff, so you start losing that actual connection. And so it very rarely is used. A lot of people don't mess with pixel space. Usually they just stay in root space if they're trying to stay in the actual pixel image. Then there's the coordinate space tree. This is when you start creating your own fixturing. So it's always going to start with the image root space. Then it knows the space that you've created, and it knows how they are related to each other. So you have what was acquired by the camera. Then you can go down where you can do a calibration based off the upper left-hand corner, or calibration based off of this label. So I'm still staying in millimeters space here, but I know how they're related back to the root space. In this one, I'm going to do like our Cartesian coordinate system from high school geometry. Going to do bottom left-hand corner, y going up, x going across, no problem. So I have a right-handed calibrated in inches, but it still knows how it relates back to the root space. Okay, just calibrates it for us so we get real-world units. Or I can just have it fixtured. Still in pixels, just going to shift according to the part shifting, where it finds that shutter to be. It's going to move everything accordingly. Now your selected space is your current space. So whenever you create a new space, that becomes the selected space. But you can go in there and you can force it to be any other space that you want, but usually we want to stay with what the selected space was, the one that we have created. Create a new image through some transform will add to your coordinate tree, okay? And it already maps what's going on. So as you start going between it, it knows what's going on behind the scenes. But still, that's how when you start pulling things in from another coordinate space, you have to be careful of what you're putting in for your units for the tool, because the tool is now acting in that coordinate space. Okay, it's going to make more sense when I do the caliper tool in a moment, well, after we do calibration, because then I can put in what the space should be between something in millimeters as opposed to put it in pixels, because that might be something that's more readily available for me. So let's talk about the fixture tool. So the fixture tool is going to allow for me to adjust my space according to where my part is, so that when I put some tools on it, like let's say I want to put a caliper tool on it, and a caliper is just basically an edge tool. We'll get to that in the section after next. That as my tool turns, it turns as well. So I keep measuring the same thing. Doesn't matter where my part is, but as long as it finds my part, as it rotates, it keeps the regions staying on my part so that they are measuring the exact thing. If I didn't, I would still have my little region sitting up here, and it would be reading nothing. So I want to keep my region small and moving with my part. That's fixturing. So the very first part of a fixture tool is usually using PatMax. The reason we want to use PatMax is because you get both translation and rotation all in one tool. So it just makes things so much easier for us. So the first thing we have to do is find something unique on the part. What they've done is they found this right ear. They trained it and they said, okay, I'm going to look for this ear. Then what they do is they're going to attach the output image to the PatMax tool, because we're taking what's acquired from the camera, and also the output image to the fixturing tool. Okay, we need to make sure we're using the same input image on both the PatMax tool and the fixturing tool, since we are basically combining them with each other. If we don't do that, we're comparing apples and oranges and things could go bad. Right, that's how they're kind of knowing the relationship. Same image is coming into it. So they're like, yeah, we see the image, I understand the transform coming in, I understand the pixels coming in. Then what I want to do is I want to take the pose from it, and it will take whatever the first pose, so the highest score. I'm going to take the pose and feed it right to the transform. So it's going to take that X, Y, and rotation from my PatMax tool and feed it right into the fixture tool. So as my part rotates, the fixture tool will rotate accordingly to it. Now I could break them out if I want a separate X and Y but no rotation or something. If I want to break them out individually, I could. And I could feed them in individually. But since I have everything coming from one result, why bother? Let me just feed it all in. Then of course we need to run the tool group. Okay? So we run it and we see how it works. We'll see that it runs down there, and it's going to tell you some information like where it changed its translation from the upper left-hand corner, how it's moved over, whether there was any scaling difference or rotation. Now you could force those to 0, or you could say, yeah, I knew that there was a little movement in there, I'm fine. It's close enough for me, I'm going to keep that. Okay? So all in all, that's really all you need to do for it. If you want to tweak them, you can, but that's all you need to do. Because what's going to happen is your fixture tool is now going to have an output image. And the output image is going to be the fixtured image. So now my caliper tool would feed from that output image so that as the part rotates, it rotates with the image. It basically goes in, shims back up the part, and then puts the tool where you originally had placed it. So as it moves, so doesn't the region for your tool. Neat, cool. So now notice that as I'm moving, I have placed my fixture here to find these two edges here. And notice if I rotate it, it's still moving with my part, it's still finding the two edges. Perfect. So it's a dynamic region at this point. We love dynamic. So that's our fixture tool. Now let's say your boss decided you don't get PatMax. We don't need PatMax. You can do this all by yourself. You can do this. So then what you might need to use is a fixture endpoint to endpoint. And that's where you're actually finding where these points are from other tools, and then feeding those points into a fixture tool, so you're saying this is what my transform is. Remember, PatMax takes care of that all for you. But this is a case that you're not using PatMax, so you have to come up with it yourself. So we still want to keep our caliper here, but what we're going to do is we're going to use a blob tool, which we'll talk about the blob tool in the next section, to find these two holes, and we're going to use those as our fixturing points, because 2 points are going to allow for us to have a fixture. We know movement versus them, and we know angle, because it's going to look at the 2 points with respect to each other to know how the part has moved. So we would, of course, first find the blobs. So we'd feed that into the blob tools. And then we'd get that fixture endpoint to endpoint and feed the same output image into it. So they should be using the same. The image that goes into finding those points need to be the same one going into the fixture tool, so we're comparing apples to apples. Then what we need to do is we need to bring out the center of mass x and y of our second point. The first point's already there, but the second point needs to be brought out. So you would right-click and say Add Terminals, and this is a bad example because they say item 0. It should be item 1 that we're pulling out. So item 1 will be our second result. So now within our terminals, we're going to have center of mass of our 0, so our first one, and center of mass x and y of our second point. We would feed those into the 2 points sitting here with our fixture endpoint to endpoint, so it knows what those 2 points are. Then we go into the tool itself, and we decide, well, what are the degrees of freedom we want to compute? And that makes sure that we have enough points. Because otherwise it's going to let us know, wait, you don't have enough points to compute that type of degree of freedom. If we're just doing translation, just movement, 1 point's enough, because it knows where that point is. If we need rotation and translation, we need 2, because 1 will show us where we moved, and then they need angle. If we want scaling, aspect, rotation, and translation, that's 3. And if we want scaling, aspect, rotation, and skew in translation, we need 4, though we can get away with 3 if they're not collinear. If none of them are collinear, then it actually derives what that 4th point is, and it pulls that out. Then you just go in, grab your reference image. It's going to give you an origin point. You can move where that origin point is. When I use the fixture tool with PatMax, the origin point ends up being your PatMax origin. That's where it grabs it from. You could always move it from there, but it grabs it from the PatMax point. But this one you can set, where do you want it to be? Do you want it up here? Do you want it maybe based off of here? Where do you want that origin point to be? So you can, like I said, move where you want the points to move to. And you'll notice that people have asked me for, hey, I can stretch out the lines. What does that do for me? Well, if you're trying to run it like maybe along a straight line, it helps you with rotation. Because run it long and try to balance it along the line, then you can line it up. Because sometimes having it too short, you're not sure, you know, am I really running parallel to the edge I'm looking for? Then after you run it, no problem. It still comes out with an output image. Acts the same way as the fixture tool does. Okay, it's just derived as a different way. So let's reduce this. Let's close this off. So right now we already have a PatMax tool, but what I want to do is I want to do a histogram. Okay, so what I want to do with my histogram is, let me go ahead and I'm going to run this, turn this over, because I am going to do a presence and absence on these little dots right here. I want to see if that connector has its pins in there. So I'm going to go ahead and first what I'm going to do is I'm just going to add a histogram tool so you can see what's going on here. So I'm going to go ahead and go into my tool group list. Now notice your histogram's not in this list right here. That's because it's actually part of the image processing tools. So if I open up image processing, there's a cog histogram tool. They kind of put anything that deals with grayscale values, changing of grayscale values, inside image processing. Even though the truth is this doesn't do anything to the image. It just counts them. So I'm going to drag the cog histogram and drop that right into here. My input image. If I right-click and say Link From, notice I only have one right now. So I'm going to go ahead and take it from the actual live image. Let it run once, run the tool, And right now my shape, it's using my whole image. Okay, that's not going to help me. So I'm going to go ahead and I'm going to switch this to be a circle. And now, inside my current input image, I'm going to take my circle, bring it down here. Let's make it a little bit smaller. And notice I'm putting it here. Notice I am not picking up any of this white circle here. Why not? Because it's going to affect my histogram. I'm going to bring in some extra white values, which should always be there, which is not going to give me a very good result. It's going to throw off my average value, which that's not what I want. I just want to check these pins right here. So if I go ahead and run it right now, notice that my results tell me information about what's going on here. It's saying that my variance is at 54.99 and my standard deviation is at 74. Now if I go ahead and take a look at my input image, you'll notice that it's not showing my actual graphic yet. So I need to actually say show region and run it to see where my region is. Now notice that, here's my region again right here. I'm going to go ahead and run it. If I move my part, uh-oh, what happens? It doesn't track with it, okay? And notice it's still running my results here. But it's very different between, you know, coming in here versus maybe coming out here. I mean, look how this throws everything off. If I come out to this area, even worse. You know, definitely throwing things off. So let's try to get that fixturing involved. So let me go offline again, close that. And I'm going to add a fixture tool. So let me go ahead and say add tools. I'm going to look underneath calibration and fixturing. I'm going to grab the fixture tool and I'm going to stick it before my histogram. Okay? Because in just a moment I'm going to disconnect my histogram and add it to my fixture tool. So the first thing is the input image that my fixture tool has. What is the input image I should use? The image source, the actual acquired one. That's the only one I can use right now, but I'm also using the same one that my PatMax would use. Okay, so I'm going to feed that right in. Then I'm going to take my get pose, because this is going to grab me both the X, Y, and rotation all in one. If I grab my get pose, I just bring it right down to my transform. I could go down to my transform, and it shows me whatever options I have. So right now it's telling me either my PatMax or my SearchMax. Well, which one am I going to use? My PatMax, exactly. So that's the one I already have it connected to, is my PatMax. So let me run it once, and let's see what's going on with my fixture tool. So it does transform it a bit. Notice that it puts my origin point now based upon where it found the PatMax to be. Remember, I put it in the center of the O, so that's where it's being based off of. On my rotation, I got a couple degrees rotation. I could force it, but I'm fine. I had moved it just a little bit beforehand. And my scaling, almost exactly 1, so I'm good with that. So now what I want to do is, instead of my input image for my histogram tool going from the actual acquired image, let me go ahead and unlink this. And now notice that if I say link, I now have 2 images to link from. I have the one coming from my fixture tool or the one coming from my image source. Which one do I want to pull? The fixture. Why the fixture? Well, you want it to track with the part. So right now I'm watching the word cognix, and as the word cognix moves, my part is moving, so it will track in that same basic area. So I'm going to say my cog fixture tool, and go on in here, let me run it. Now, mind you, it just failed here. Histograms should never fail. But let's see why it failed. If I take a look at this, notice it had moved my fixture my region way out here. Because it was the upper left-hand corner and dropped down to the O, where I had put it would have dropped down relatively according to it. So you should always do your fixturing first before setting your regions. Otherwise, you could have them go outside of your field of view. But that's not a big deal. I'm just going to move it back in. Move this on over, and then I'm just going to, once again, move this to be about right there. Perfect. Let me go ahead and run it. We can see with our results that indeed it's there. And if I go ahead and let me reduce this and say run, notice that inside my histogram image right here, it is staying, for the most part, with my part. Okay? Notice it's moving a little bit as I'm moving up here, but that's because my Cognix is almost outside the field of view, so it's getting thrown off a little bit. And also, my camera is actually skewed. I'm coming in at a kind of a parallel type. Not really parallel, sorry, a non-orthogonal. So like about right there, that's almost perfect for me. Now, if I switch to the other side, notice it still tracks with it over there. And so when something's there, my standard deviation is up around 64, 75, and I've got a pretty large variance. If I switch it over to be where there's nothing there, notice my standard deviation went from like 75 down to 3, and my variance went from like 57,000 down to 9, 8, pretty small. Okay. Now one thing I want to show you though, notice if I go out here to this one, my region's not showing there. Okay. Anyone have an idea why it's not showing there? No, it's found it. No, it's found it. It's a little small nuance here. You're close. You're very close. Right now we're looking at last run image source output image. Notice now if I pull this down, I also have a last run cog fixture tool output image. That one has my fixtured information. 2 separate images. One image on my image source is the actual one coming from the cameras and any tools that are using that image. And then my actual fixture tool is now showing you any tools that are using our fixtured image. Cool. Neat.